GitHub Copilot Spaces brings powerful context management directly to your development workflows. Let's start by creating a space. I'll click Create Space and give it a name. I can assign it to myself or my organization so my whole team gets access. Next, I'll add instructions. Instructions tell Copilot exactly how to help my team. These instructions can be very specific. I can even tell it exactly which lines of code to update in specific files when adding new features. Here's where it gets really powerful. I can attach my entire repository or select specific files from it. I can also add external documents like ADRs, design specs, and performance reports. I can also link issues and pull requests, so Copilot understands the full context of how features actually get implemented in our project. Now, I can query the space using my favorite model and get expert guidance. I'll ask it to add a new pattern detection category for accessibility issues. In this example, watch how Copilot responds. It knows our exact JSON format, our severity levels, our testing patterns. This isn't generic advice, it's grounded on our knowledge base. I can access the same space directly in VS Code with the GitHub MCP Server's Copilot Spaces toolset. With the remote MCP install, Copilot can pull context from any of your spaces when you're coding. I can ask Copilot to list my spaces, or I can get a specific one by using get Copilot space and the name of the space. Once loaded, Copilot has all that context. When I ask it to generate an implementation plan, it creates one that fits perfectly into our existing architecture, not random boilerplate. And it stays synchronized in real time. If someone updates a document in the space or adds a new requirement, that context is immediately available. That's the power of Copilot Spaces. Turn your codebase, docs, issues, and project knowledge into an AI expert that your whole team can use. Happy coding! Hello, everyone. Welcome. Andrea here. Welcome to Open Source Fridays. If you are new to Open Source Friday, every Friday at 1 p.m. Eastern, we sit down with open source maintainers, contributors, founders to talk about the projects they're building, the communities they're growing, and of course, the problems that they're solving. And today, I'm super excited because we're going to be talking about Cilium. And if you're running Kubernetes in production, you need to know about this. It's an open source networking security and observability solution built on eBPF technology. And you're about to learn why it's really changing cloud native infrastructure. And I am thrilled because joining us today is Bill Mulligan, who is a maintainer and member of the eBPF Foundation Governing Board. Thank you so much, Bill, for taking the time to be here today.
Yeah, thanks for having me.
And of course, you are watching this as a pre-recording event, but please drop your questions in the chat. I will be monitoring the chat in real time and passing along these questions to Bill. So we'll be able to respond during the premiere. And again, just sit back, relax, and get ready to learn. Can we start with the very basics? What is Cilium and what kind of problem does it solve?
Yeah, definitely. So as we kind of made the transition from like physical hardware boxes to do our networking, to doing our networking in virtual machines. And then finally, we moved to the whole world of containers and cloud native. And we still need to connect all of this together. Like if you think in the world of distributed computing, basically everything's going over the network. So it's the critical component that you need to have. And the question is, as we're moving from the world of physical boxes to containers, like software containers, like how do we still keep everything connected? And that becomes an even harder question because it's not, a physical box that you just can like plug something into. It's thousands, millions of containers spinning up and down all the time. You have these really dynamic, ephemeral environments. You can't kind of track each one of them individually, and you can't go over and plug cables into each of these containers. So then the question becomes, how can we make sure we have reliable, fast, and performant and efficient networking between all these containers at cloud native scale. And that's where Cilium comes in. It, at a very basic level, provides networking in the cloud native world. So connecting all these containers together, especially in the Kubernetes world. If you're running a Kubernetes cluster right now, it's extremely likely that you're running Cilium. It's the default AKS. So if you're in the Microsoft ecosystem, you're running Cilium. It is the underlying fabric for Google's Data Plane V2. So if you're on GKE, you're running it. And it's also a plugin in Amazon too. It's also supported on hundreds of other cloud providers. All the major Kubernetes distributions also support Cilium. So if you're running Kubernetes, you are probably already touching Cilium, whether you know it or not.
Oh, that's very interesting. So I understand that Cilium is built on top of eBPF, right? And I personally, I'm not super clear on what eBPF specifically is. You just shared the problem that Cilium solved, but could you help us understand why is eBPF such a big deal?
Yeah, definitely. And I think eBPF is an interesting technology and concept to kind of wrap your head around, especially because it's like a really deep, like Linux kernel technology. And immediately when in Isovalent, I remember being like, yeah, this eBPF something like we do something. Little did I know, I like onto the first team meeting and there's like Daniel Borkman, one of the co-founders of it. He's like, I just hacked together a little demo and just like, we're like looking at zeros and ones on the screen. I have no idea what's going on anymore. So eBPF is actually trying to solve a similar problem to what Cilium is, right? Cilium is 35 years old now. So really decades old technology when you think about it. And over time, as you get older, like me, you just kind of accumulate things. There's a way of doing things, and you don't quite move as fast as you used to. And so the question kind of became in the Linux kernel, right? It's deployed on billions of devices worldwide. It's deployed on your phone. It's deployed in your data center. It's deployed even in your car, right? And so to make sure that there's the stability that all those different places need, kind of the innovation cycle slows down. You need to provide a certain stability to your users. So you're not just like breaking things left and right. Half the internet goes down. So then really the question becomes is like, how do you balance this stability that the Linux kernel needs while still enabling the flexibility and the innovation that, that new technologies require? So things like cloud native, how can we route so many packets so fast? How can we connect all these containers together? How can we add programmability back into this decades old technology that still needs to be stable? And that's where eBPF entered the scene. So you have the Linux kernel here. And the traditional way is if you want to add new functionality into the Linux kernel, what happens is you go into the mailing list and you like start emailing back and forth, which if you don't know a little bit about.
A little bit painful.
A little bit painful. Make sure your like emails are 80 characters in line spacing. And, eventually after about a year of fighting, you can get something into the Linux kernel, right? And so great, your functionality is there. But then for you to actually be able to use it in production, I feel like nobody's running, yep, let me just download Linus's tree and then like that's where they're going to run in production. I mean, more realistically, you're running an LTS supported version by whoever you're getting your Linux from or your underlying OS. And that's going to be probably a year or two, maybe 3 years behind. Or if you don't like updating things, maybe 5-6 years. So for the latest innovations to get back to you, like it literally can take years, right? So this innovations like cycle flows down even more. We need stability. It takes years for things to reach users. And so the question is, how can we add new functionality, new programmability back into the Linux kernel? And so what eBPF allows you to do, it kind of creates what we say is like a sandbox environment, like a safe environment inside the Linux kernel to insert programs that change the functionality of the kernel. And so the comparison that people like to use is eBPF is to the kernel what JavaScript is to the browser. And if you kind of like think about what this example was, right? Before JavaScript, you had these static web pages. You're just kind of consuming information. It is what it is. And then once you add JavaScript in, you can start adding interactive elements. Like, right, you click on a button, something happens on the web page. And it's the same way with eBPF. You instead of clicking on a button, your application is making a syscall saying, I need to access this specific file. And eBPF can say like, you're accessing this file, let me run this program and change the functionality. So if it's an attacker, we all love cybersecurity right now, an attacker is trying to access this file, eBPF can be like, this process is not supposed to access this file, so we're going to block that. And so this functionality, if you wanted to add that, it could take years. But the great thing about eBPF is you can write the program, you can deploy it without restarting your operating system, and then you can have that new functionality in production on your running system. And so like some really cool examples that I've seen is like there's bugs in Linux kernel, and people were able to mitigate those bugs by deploying eBPF programs that like fix the system. So right, really cool like on the fly functionality, allowing you to do things. And I'm actually going to Linux Plumbers Conference in Japan. And funny things on the schedule is it's kind of like how all the Linux kernel engineers get together. And one of the things was the eBPF-ification of everything.
That is a fantastic name for a segment.
And I think this kind of captures the moment that we're in. And so what I was talking about, like this kind of like years-long innovation cycle, we're kind of like eBPF as a technology is 10 years old. And so at this point, most people, not all, most people are running a kernel that supports eBPF. And so that innovation is available and they're able to run programs on their system and allows you to do a lot of different things. So, right, I gave the cybersecurity example, but eBPF, for instance, with Cilium, does a lot of stuff with networking. It has cases like profiling. A lot of tools are using it for observability. Runtime security, I don't know of a single vendor that's not using eBPF in the new product launches right now. Microsoft is also using it in some of their products. It's coming, eBPF for Windows is coming. So it allows you to bring innovation from years to, it can be like hours, minutes, right? You write up the program, you deploy it, and then you can, for instance, what's going wrong on the CPU? You can write up the program, deploy it, see what's going wrong, and then take out the program, and then you've solved your problem. I mean, that's a really cool thing. It's like this innovation cycle, what you can do, what you can think about. It's like the idea to solving your problem is just like years shorter.
That's amazing. So Cilium is providing networking, security, observability. That's very, very interesting. And the eBPF is like a massive ecosystem now too. Like Cilium is one project there, but it's a big part of this sort of technology that's growing. I do want us to go back to that at the end, because you know that you have a role in that, being part of the board. So yeah, it'd be great for you to share later as we're closing out, like what's happening in that space there. But when it comes to Cilium, why would developers choose Cilium over, I don't know, are there any other open source projects or not that sort of offer that kind of networking? What's sort of the differentiator for Cilium?
Yeah, definitely. There's lots of different projects that provide networking in Kubernetes environments. So what you should know is Kubernetes by default doesn't come with any networking. So if you create your Kubernetes, you need to install some type of networking solution because it doesn't come with it. And there's other projects. There's Cilium, there's Flannel, there's Calico, there's Weave, there's Qvote, OVN. There's lots of different solutions. And part of my role is like going out and talking to end users. But I think this is really fun because I get to find out like, yeah, why would you choose Cilium over something else? And talking to the end users, I would say there's kind of 3 main reasons that people will switch to Cilium. And I think they actually really tie really well into the 3 main use cases of Cilium. So networking, observability, and security. So the first one, networking. Number 1 is almost nobody runs just a single Kubernetes cluster, especially as your business, you're like growing it, you're going to be running multiple Kubernetes clusters. And so what Cilium does is it allows you to have multi-cluster mesh or like cluster mesh. And this allows you to mesh multiple clusters together in a seamless way. So this has a lot of benefits in terms of like failover, service discovery. You can have a service in one, it can be discovered in another one. If one cluster dies, you can fail over to another one. As clusters go in between things, so you have your database in one region, you need to access it somewhere else. You can do that seamlessly, right? This is a really complicated thing to do, but Cilium can make it seem like there's just one Kubernetes cluster, even though you're running.
Amazing.
So that's really cool. So that's networking. Number 2 is around observability, right? Observability is really big topic, especially as I said before, like, distributed computing, everything's going over the network. When DNS isn't working,
Right.
so then the question becomes, how can we debug this very complex network?
Mhm.
Cilium does that with a sub-project called Hubble. And what Hubble allows you to do is, with these eBPF programs, you can see everything that's happening in the Linux kernel, right? It's embedded in the kernel, it's seeing all of it. And so it's taking the information right off of the wire and visualizing it for you. So you can get the Hubble network flow logs, and it provides you a service map too. So you can see where things are going. You can provide the self-service to your developers so they can debug their own applications. I actually just did a case study with ESNet, which is the Energy Sciences Network in US. Super cool. They're running only Kubernetes, like really advanced stuff, connecting all the national laboratories. And the quote was, "Hubble's a godsend. It saves me days."
Wow.
So yeah, like I think everybody knows debugging is complex, and Hubble, through its observability of everything that's happening on the network, makes it really easy. So that's observability. And the third one is around security. Obviously, I don't have to explain how big of a topic security is right now.
Yes.
A couple of things that Cilium does that has people adopted. Number one is around network policy. Kubernetes comes with Kubernetes network policies, and these are layer 3, layer 4 network policies. And they're good for kind of starting out, but most enterprises have a lot more complex requirements. And Cilium has additional types of network policies. So things like layer 7 network policies that allow you to block or deny things based on layer 7 things. It allows you to do this network policy across multiple clusters, like through the cluster mesh that I was talking about. It allows you to do things like host firewall. So doing network policy for the host. So a lot of things about how do you secure the network in terms of firewalling, or, we also call it like microsegmentation. How do we segment all the different tenants that we have? So this network policy. The second one is around encryption of network traffic. There's a lot of regulations talking about how you need to have data in transit needs to be encrypted. For Cilium, that's just one switch. It makes it super simple to meet the regulatory requirements. And then the third one is this sub-project of Cilium called Tetragon. And this is using eBPF for runtime security and also for runtime enforcement. And so what it allows you to do is, eBPF allows you to see anything on the host. And so you can look for anything that you're looking for. Think about what is your threat model for your infrastructure, and you can pinpoint those exact things. And what this allows you to do, rather than being like, oh, we need to look at everything, like we need to defend against everything, you can be like, no, these are the security risks that we have, and we need to monitor these things specifically. So you get really low overhead for really high and really fine-grained security, and being able to do that in an efficient manner, and then also being able to, since you're in the kernel, like doing runtime enforcement, blocking things that you don't want happening. And so, yeah, like people really choose Cilium for networking, observability, and security.
I mean, it's like the complete package there. Amazing. Can we see it in action, please?
Yeah, sure. So I have a little lab here. Let's see.
And then I'm going to share also on the links, on the notes, the links to, of course, the repo. And then love to share that case study that you mentioned. That piqued my interest as well.
Yeah, so this is a terminal. So this is one of the getting started with Cilium labs. I think it's quite cool because this is an actual live Kubernetes cluster, and we can actually walk through the process with Cilium here. Yeah, let's see. So the first thing is like, how do you install Cilium? You can install it with the CLI. And so you can do like Cilium install. And so what we're doing in this lab is we're going to install Cilium, and then we're going to do some of the network policies that I talked about. So what you're able to do now is see, is Cilium actually installed? So we can see some of the Cilium things are coming up right now. Like they'll slowly update as our cluster is getting up and running. And I like this lab environment because it allows you to actually get like hands-on with the thing and see how Cilium actually runs in production.
It's even a quiz like that.
Yeah. See, allows you to, this is embarrassing. if I get this wrong.
Wait a minute. Install Cilium on a cluster. And listen, audience, please go ahead and post your answers. Check the Cilium status of the cluster or install Kubernetes. Is it all of them or the first and second? First and second.
Just the first two. Yeah.
Oh, imagine you got that wrong, Bill.
I know. The more prepper that they've had in school, right?
So much pressure.
We're watching this. Yeah. And so this is kind of, so now we've installed Cilium, we got the network connectivity that I was talking about. Is going to talk about like the network security part. And so what we have here is like simple microservices application. We got the Death Star from Star Wars, and we got the TIE fighters and the X-Wings, right? The Empire is trying to protect the Death Star against the X-Wings. And so the question is, let's first deploy all the things into there. We can see Death Star is created, the TIE fighter is created, and the X-Wing is created. Then we can check that. We can see all of our TIE fighter and X-Wing pods are running. And then we can see that they're each in namespaces and that they're already running. So we can check that. And then now what we're going to do is who can access the Death Star, right? This is a classic question. Security is, how do we lock down access? Who has access to what? And so if we look at this right now, we can see that the TIE fighter is able to land on the Death Star, right? That's what we want. And now the question is, the X-Wing, the rebels, can they also land on the Death Star? And they can, right? So this is the attacker coming in. They're like trying to shoot down the tube, blow up Death Star. That's not good, right? Security policy is missing. So the question is, how can we change that so that we can start locking down our namespaces so that the attackers can't come in? And I think this is like the interesting thing about like Cilium. When I was kind of talking about this transition from these hardware boxes where the IP address is the most important thing to this cloud native world where everything's dynamic and changing all the time, right? You can't have a world of security based on IPs because they're changing all the time. And so the whole model, the security model of Cilium is moving to this cloud native world. We're giving everything a label, a name. And so if you think back to like kind of like the DevOps world where you're moving from like pets to cattle, what these labels allow you to do is like label all of these are cows, all of these are not cows, right? And so, or these are TIE fighters, these are X-Wings, and you're able to apply policies consistently to things that you've labeled, even as the IP or other types of identity, the container is changing, right? You can have a consistent way to enforce policy, even in this dynamic and cloud native world. So now what we're doing here is we're in the world of Kubernetes, we love YAML. And so we're actually trying to, of course, we need to—
No comment.
Yeah, that only the Empire ships are going to do it. So here we're seeing that we're restricting Death Star access to Empire ships only, right? So we can do org Empire class Death Star. And the other thing is we also want to only allow access with TCP on port 80. So I'm trying to deploy this. Yeah.
And so you're basically just now like applied that or wrote the network policy, right? That's like the YAML part of it. Okay.
Yeah, exactly. And then, so what this allows us to do is to like look over. So this is switching from like the networking, you saw the security part, and now this is to the observability part. So Hubble that I was talking about earlier is providing us this service map, and it's allowing us to look at what is allowed to talk to what in the Cilium world. So you can see like the Empire is able to talk to outside clusters, any pods in the namespace and everything in the cluster. But things outside the cluster aren't allowed to talk to the Empire, right? And so these are the network policy things that we have deployed, right? And so as things get more and more complex, it's important to be able to actually deploy these into the namespace. And not only that, but also then reason about how your actual security policies are deployed.
That's very cool. And Hubble is part of that comes with Cilium, right? Like I'm able to have this visualization in Cilium. Cool.
Exactly.
And what does it look at? Like, does it look at every packet or is it Is it
Yeah.
a sample coding scenario, or how does it actually?
No, so it's actually looking at all the packets. So there's kind of two ways to do it. One is like here in like the Hubble UI,
Mhm.
and the other one is just like you can get the flow logs through and you can get like the determinations for all the packets, whether they're dropped and like the reason that they're being dropped too.
I like
So
this. This is my favorite.
yeah,
Visually amazing.
people love Hubble. Yeah, and maybe I can kind of like walk you through a little bit of the Cilium website and kind of like use so people can understand.
Sure.
You've seen a bit of the code. And so this is like the use. So if you want to do the lab, just go to the start lab here. And then there's the getting started with Cilium lab. You can walk through. I don't want to walk through all of it because then I'd give away some of the answers at the end. And you get a little badge, and I want people to feel, the satisfaction of earning the badge.
No cheating and open source Fridays.
In the beginning, I was talking about how Cilium started as this CNI in Kubernetes, but in networking, it's actually not always DNS. There's a lot of other complicated problems to solve. Things like layer 4 load balancing, things like BGP if you're an on-prem like bare metal data center, meshing multiple clusters together, service mesh, host firewall, ingress. There's lots of other networking things that Cilium has slowly kind of expanded out into. And I think the choice that a lot of people are making right now is like, okay, I can either deploy multiple point solutions, or I can have like one kind of consolidated stack that solves a lot of different networking challenges in the cloud native world. And so that's why a lot of people are turning to Cilium too. The next part is around observability. So the service map with Hubble, metrics and tracings, doing the network flow logs, and having, visibility into different like network protocols. So that observability part, that saves you a ton of time. And then, like I said before, the last part is about security. So the encryption, the network policy, the runtime security type of things. And I think I like the website because you can kind of walk through each of those use cases. Like, say, for instance, I'm interested in like layer 4 load balancer. We'll kind of walk you through why you'd look at that. And then we also have industry vertical pages. So for instance, if you're a financial services company talking about like the different things that Cilium can help you solve in your industry, the different users that have actually done that. So for example, Bloomberg here talking about like how they found, obviously you want to secure financial data. So were super helpful for us. And then the last part here is like a lot of people don't talk about, and I think this is actually a problem across a lot of open source projects. They're like, here's my gadget that does this thing. And what we need to be able to do as open source maintainers is really connect that specific use case or feature or whatever back to the actual business value of our end users. Because yes, you can get developers to do it, but if you want to like have people invest in the ecosystem, you need to be solving business problems too. So when I actually think about like what Cilium does in terms of like business problems it solves, the ones that we came up with is like zero trust networking. How do we secure a perimeter and inside of it? How do we do network automation to reduce the toil and overhead in our really dynamic cloud native systems? How can we save costs in terms of compute and also carbon? How do we connect multiple clouds together? What's our failover strategy? How do we do that? And the last part is like tool consolidation. We have lots of different things that we can do. How can we worry about network policy, multi-cluster, load balancer, ingress, kube proxy, and simplify that all down? And does a great job of doing that. So it reduces the complexity for your team. So here's an example from a cloud provider here, actually based in Berlin, near me. So I'm replaced everything that had to do with networking. So in one sense, it's just the CNI plugin that I talked about at the beginning, but and it removes so many of the tools that we didn't need anymore. And so I think that's the thing is like, as an open source maintainer, how do you connect back to the business value that the users are actually going to see too?
This is a great example. And if you are an open source maintainer of a project that can support like this type of just laying out all the verticals, and like, that's brilliant. That's fantastic. It's a good example. I wanted to ask you, because you talk about business value also, if I want to migrate to Cilium, or like, what's the operational cost, like the overhead of running it? Like, I mean, in terms of like talent, do I need a full team, like a platform team needs to manage this, or can general DevOps people do it? When we're talking about like what's going to cost, I guess folks can reach out to Cilium and figure out. But I wonder, like in terms of like human capital, like what does that look like?
Yeah. So I think this is kind of an interesting question. I think it's like at one layer, you're going to need to have a networking solution in Kubernetes. Like you can't. So I think the question is either like if you're going greenfield, like probably you're going to have it. And like I said, like a lot of the cloud providers like Azure and GCP, you're already getting Cilium. So there's not really a cost of doing that. And then it depends on how deep in the weeds you need to get with networking. In terms of migration, we actually have a couple like migration labs that you can check out.
Nice.
And the project has done a lot to help ease the migration from whatever other technology you want into it. And there's also kind of like multiple layers, and not you have to go full blown Cilium at once. So I think Cilium is like a collection of different things that you can do. So like the first one that I see a lot of people adopting Cilium is like, man, we love Hubble, we love this observability component, but we don't change our networking layer. And what we're able to do is your existing CNI can stay in there. You do network chaining. So essentially you put Cilium on top and you're able to get the network observability from Hubble on top of that. So the original CNI routes all the Cilium, just sees where they're going and then be like, hey, this is the problem in your network. So you can do it incrementally too. And then once you have it in chaining mode, you can say, hey, Cilium, we want you to do the network routing. And then gradually it takes over and then you uninstall the other one. And then in terms of like the team competency, I think this is an interesting question, especially as we're kind of like in this moment in cloud native where Kubernetes has kind of had its moment. Some people are moving to cloud, some people are moving back out. And we're kind of seeing this combination of like, how do we manage, you're looking at our whole IT estate. You know, we have some stuff in cloud, we have some stuff in the data center. There's going to be like NetOps teams that are running stuff in the data center, like, you know, it's not Cisco switch. Let me go plug it into the wall. There's going to be people in the cloud is like, I've never been in a data center. And so I think it depends a lot on like how your IT estate actually looks like in terms of what things. So if you're running a bare metal data center by yourself and you're looking at things like BGP and FRR and a bunch of other acronyms that I don't really understand, then you need to be kind of like more deep in the weeds of Cilium. I think the thing there is there's a lot of people with a lot of networking expertise, you know, have spent their whole career building up expertise in networking. And they're now having to go to the cloud native world. And the question is, it's not, we're doing anything new. It's we renamed everything differently. And the hardest problem in computer science is naming, right? And so since it's a new paradigm, we're like, yes, we're going to rename everything. And so getting these NetOps people into the cloud native world, a lot of it's just like, you already know how to do this. It's just going to look a little bit different. It's named a little bit different. Yeah.
Okay. And that's great.
And then if you're in this cloud world, it's kind of like the question, how much do you need to bring back? How much do you care about the network? And yeah, I think the great thing about cloud is some people don't have to care about the network at all. You know, that's the thing. Like for some people, Cilium just works. You know, I install it, it routes the packet, and I never have to worry about it again. That's the thing is like when the technology is seamless, you don't have to care about it. So I think it really depends on how deep in the weeds you need to go with the networking.
Amazing. Okay. Well, I think a lot of people are going to be very interested in spinning it up and giving it a go. And then for people that are watching and are thinking, well, you know, I have that level of expertise in networking and I want to maybe contribute to the project. Can we talk a little bit about how folks can get involved with the project?
Yeah, definitely. So Cilium is actually the third fastest moving project in the CNCF, which
Cool. This is epic.
Thanks. And the main repo just passed 1,000 contributors, which is not as some developer tooling, but like as like infrastructure tooling, I think that's wild.
That is a lot. Yeah, no, that's a wild number. Yes.
So yeah, we're always looking to have like more people get involved. We have lots of different contributors from all across the ecosystem, multiple cloud providers that are relying on it, are contributing. And I think a lot of people have asked me in the past, like, hey, I'd like to get involved in open source. It's done a great thing for your career. I'd like to do the same for mine. And the advice that I always give people is actually not project specific. I think you can apply this to any project. It's like, pursue whatever you're interested or passionate about, because that's what will take you the furthest. And so I think you should look at solving your own problems first. I can tell you, like, my first 2 contributions to open source was like the first one why I created my GitHub account was because I was writing my master's thesis, and this open source software that I didn't even know what open source was, I downloaded, wasn't working. I was like, I need this to be fixed. I was like one of the very unhelpful people in open source on that one, I'll admit. My second contribution was I was writing an article about Kubernetes, and I was reading through the documentation. I realized that there was a link that was broken, and I was like, okay, well, I need to know where this information is, and probably other people will in the future. So let me fix this broken link. And it's progressed a lot since then. I'm also a maintainer.
That was the gateway.
Open source projects, but right, it's kind of like solve your problems and pursue what you're interested in, right? If you're deploying Cilium on your home lab and you're like, okay, this specific feature doesn't work on Raspberry Pis, I need to solve this because I want to do this thing on like my Raspberry Pi cluster, right? Then you're going to be intrinsically motivated to solve your own issues. And then it'll take you a lot further than being like, hey, I want to contribute to a project. Can you assign me an issue, right?
Yeah.
Because I don't, maybe like you got busy, it's nice outside, you want to hang out with your friends, but if you're like, oh no, like this is actually broken, I need to solve for me, then you're going to be motivated to fix it. And I think when you have that intrinsic motivation about whatever it is, it's going to take you a lot further than somebody else telling you what to do.
That is the most solid advice. Everyone, please take note of that. That's fantastic advice. And thank you for sharing outside the scope of Cilium. I will share all the links to the repo, to the labs, to the amazing website that other open source projects can take note of. Before we close out, Bill, I do want to ask about the eBPF Foundation, like your role there. What is the foundation's kind of, I don't know, silver mine or top of the hill or however you want to say it? Just, I'd love to understand a bit what your role there means. And then, of course, what do you see for the foundation long-term and its role in this entire ecosystem?
Yeah, definitely. I think the eBPF Foundation is kind of at an interesting point. So it's a little bit different than a foundation like the CNCF, which is kind of like Pokemon, like gotta catch them all. It's got 200 projects now.
What?
Yeah, Foundation is actually just focused on a single project, on the upstream eBPF project. And it's like a lot of projects are going to use it downstream, like Cilium, like Falco, like Calico, like Tetragon. How can we make eBPF the best technology so that when you're building infrastructure software, it's going to be the eBPFification of everything. We want it to be the choice when you're building infrastructure platforms, infrastructure software. And so how can we make eBPF as a technology as good as we can for everyone else? And there's three main ways that we do that. Is working on, number one is how do we get people together face to face? So, we work with people all around the world. Sometimes it's good to, sit in the same room and share a smoothie or a beer or your drink of choice and like discuss the difficult problems. So we do that by funding developer conferences like Linux Plumbers Conference in Japan, like BPFCon, that'll be coming up next year. Get those people together, have the discussions, move the technology forwards. The second way that we do it is in open source. Either individuals are contributing based on their own interests, as I said, or companies are contributing based on their own interests. Sometimes there's things that fall between the cracks of all those interests, but are really good for the ecosystem as a whole. And so what we're doing as a foundation is coming in and putting money in to do that. So we're paying people to solve things that are in the interest of everyone, but nobody's doing. So that's having people submit patches to the Linux kernel to improve the testing, improve the architecture support, improve the sanitization of programs, this kind of background things that makes the technology better for everyone to use. And kind of related to that is how do we make sure that the actual technology is secure? And we also fund things like security audits. We fund threat models. We fund people to go fix security problems in eBPF to make sure that it's secure. People can use it in production. They feel safe about that. And then what we also do is we fund academic research. How can we push forward the edge of what's possible with eBPF? And so in a previous life, I was a biological research scientist. So like research is always like kind of near and dear to me. And so we actually fund PhDs to go, what can we do with eBPF? How can we ensure that the verifier is actually verifying? What are new use cases? And I think this is kind of cool because it's like both like experimental work. You don't really know what's going to come out of it. You see the outcomes, but it's also kind of like building this ecosystem. A PhD spends a year thinking about eBPF. A lot of things are going to come out that they start talking with other people in the industry. And then when they actually, go out, get a job, like they're probably going to use eBPF.
Yeah.
So it's building that ecosystem. And then the last part that we do as a foundation is just, marketing the technology. One of my favorite projects I've worked on was the eBPF documentary. You can find it on YouTube. It's really like Netflix style. Like
what? There's one of those for the eBPF? Get out. I'll put the link on the notes as well.
Yeah, it's an awesome documentary. I probably...
Are you in it?
So the funny thing is, I pulled it all together from actually it was my tweet that like started up the whole project to doing editing the final cuts and posted on YouTube. I realized I'm not in a single shot in the whole documentary. Completely lit the board on it. From CMO, just like not in it at all, like not a single one.
Wow, Bill, that is brilliant. This is like the tale of a maintainer, if ever there was.
So eBPF documentary, we do white papers, we do case studies about how people are using eBPF. We're actually funding community and ecosystem fellowships who are paying people to write labs, tutorials, documentation, anything around that. And then just kind of like bring the community together. We have a landscape that we're coming out with. I found out that there's actually 78 companies already with eBPF-based products, which is kind of mind-blowing to me, and more and more coming out all the time. So yeah, lots of great things coming from the eBPF Foundation too.
That is amazing. Okay, folks, you have to go and watch this documentary. I'm going to put it on. So I don't see Bill in it, but I know that you were doing all the work. Bill, this has been fantastic. We covered a ton. How can people reach you if they want to connect with you? Are you on LinkedIn? Are you on socials at all?
Yeah. As I like to say, I'm a LinkedIn warrior.
Thank you for that. As a Microsoft employee, I appreciate that.
Yes.
Amazing. And it's your full name, right?
Yeah, just Bill Mulligan. You'll be able to find me.
Fantastic. All right. For everyone watching, whether you call this, obviously the replay, go and try Cilium. The Get Started Lab looked amazing. Complete all of it, get your badge. And it looks epic. Go to the repo, please start the repo. Of course, if you want to contribute, the path to contribution is on the repo itself. I think you also have a community Slack that everything is in there in the site as well. And then, of course, dig deeper into eBPF. It sounds like the foundation has a ton of work ahead, and I love everything that you described that you're supporting, filling up those gaps. That was a great call out. You're like the things that no one is interested enough to pick it up, and it doesn't benefit a single company enough that they want to pick it up either. Fantastic mission for the eBPF Foundation, and thank you so much for the work that you do there. And wow, thank you so much. This has been super. I know a lot more now than I did at the beginning of this call. Thank you so much. This has been great.
Thanks for having me.
All right, everyone. Well, thank you so much for watching Open Source Friday. Go try Cilium, follow, build, and don't forget to join us next Friday.